started because a lot of people are waiting to see what this is going to be about, including myself. I wrote it a long time ago. So, polynomials. What's a polynomial?
Many numbers.
3 terms.
No.
More than one variable.
Poly means many, and nomial means term. It has many terms. Now, when we say a polynomial, it means something specific. The variables in a polynomial have to be non-negative. So you can't have like a fractional exponent because it has to be integers, and it has to be, ax cubed plus bx squared plus cx plus d. Be an example of a cubic polynomial. So all of our polynomials we're going to work with in this section are higher than 2. Okay? And now, a nice thing about polynomial is they're a continuous function. There is no vertical asymptotes. There are no breaks in the graph. And there are no holes in the graph. That's the nice thing about polynomials. There's no denominators. There's no square roots because those would be a halves. There's no absolute values because that falls under a different family of functions. So, yeah, it's the first quarter ends and it's kind of weird. So we'll see what happens with this. Sketch a graph of the function. Oh, do you remember how the functions are affected by different changes in, there are 4 ways to change a function, right? Yeah, for instance, this one, f of x would equal x cubed. Let's go to the 4 just to make me remember them. You guys probably remember them, but I don't all the time. Not all the time. A, B, x minus d plus c. What does the a do? Which one does it affect? Yeah, it affects the y by stretching it. A stretch on the y. The b is a stretch on the x, isn't it? Stretch on the x. Well, it affects the y a little bit also, but mainly it's the x. The d is a shift of the x, and the c is a shift of the y. Okay? The base function, in fact, the next kids coming in here to finish up their little test have to know what the base function is to work with it. In this case, the base function is obviously x cubed. The negative is, an x cubed looks like that snake going through there. Oh, we got rapid fire next week with all our functions. I'm very excited about that. I got to put that. Yeah, it's going to be fun. The negative does what with the graph? Flips it. I mean, so something like this. And then the 2, obviously, what? Stretches it vertically. So it's going to be a little longer, a little narrower. And then the plus c. This graph's going through the origin, isn't it? All right. So what happens if you subtract 2? What's it going to do to the graph? Yeah, it's going to knock it down 2. I just want this, so I'll just draw it in red. 1, 2. And then if you see it's plus 2, it's obviously going to go up 2. Okay? So that shouldn't be too difficult. That's a sketch of it. And you can obviously use your TI as well. Okay? As long as you remember how the 4 things are affecting the function. Okay? Should be all right. I'm going to get to solving. The intermediate value theorem. Doesn't it sound impressive? Yes, it does. Especially when I say the intermediate value theorem for polynomial functions. The reason it says, well, I know you care, so I'm going to tell you. The reason it says the intermediate value theorem for polynomial function is the intermediate value theorem doesn't work unless the function is continuous. We know the function is, for polynomial functions, we know they are continuous. No breaks, no holes in the graph, nothing. They are continuous. Okay? Intermediate value theorem. Any idea what that might mean? It is a theorem. The theorem is something you can prove. When's the last time you've done a really good proof? Geometry? We need to do one of these days in. Yeah, we'll do one. Anyway, this is the intermediate value theorem down here. If f is a polynomial function, I wouldn't write this down word for word because you won't remember it word for word. Instead, I'd draw a picture of it. Pictures are a lot easier to remember and associate with words. If f is a polynomial function and f of a does not equal f of b for all a less than b, do you know what that means?
No.
It means that the y's aren't the same and you have two different x values. Okay? So if the y's aren't the same and you have two different x values, then f takes on every value between f of a and f of b in the interval from a to b. Oh, this is what it means. If you have a polynomial, you know it's continuous, correct? Your TIs are built on this theorem. You've used this theorem a lot. Anyway, if you have an A and if you have a B, those are the x values, correct? And it says y's can't equal each other. Does it say one has to be larger or smaller than the other one? It just says they can't equal each other, right? I choose this to be f of a. Closed circle because it's continuous. I choose this to be f of b. Two y values not equal to each other. I drew the line because it's a polynomial. It has to go from the positive y to the negative y. It has to cross the x-axis. It has to. The intermediate value theorem says that if this is a polynomial, then there must be a number in between there that equals every other y number listed between a and b. That's the intermediate value theorem. Nothing big, nothing fancy. It's just stating the obvious in a mathematical way. So if you have two y values, let's say negative positive 3 and negative 4. Okay? Let's say the x values were 1 to 2. Somewhere between 1 and 2 is an x value that gives you the function value of 0. Is that correct? Y has to equal 0 somewhere. Somewhere between 1 and 2 is an x value that gives you the function value of negative 3. That's correct, right? And you can say that, and the reason is the intermediate value theorem. So there must be some c between, I don't know, a and b. There has to be a number c between a and b such that, in this case, f of b is less than f of c is less than f of a, because I have a decreasing function. Could there be more than one? Sure, there could be more than one. But there has to be at least one. Now, you can come up with everything you want for this, but there has to be one. And your TI uses this as solving calculate, or for solving equations. Okay, do you remember doing that on the TI? You don't remember at all? Oh, well, let's go to the TI and do this. I choose the following function. I choose y equals, has to be a polynomial, right? Let's do something really fun. I don't know. 2x caret 4 minus 5x caret 3 plus 2x squared minus 8. Okay? So far, so good? All right. Graph. Is there anything on the graph? There it is. I don't know. I just made it up. 2x squared minus 8. Okay? So we have a graph. So if I say window, A is going to be, what do you want to pick for A? How about negative 2 for A? And how about B equaling 5? Okay? So there's my A and my B. Does that make sense? So that means somewhere there has to be, okay, so there's my A and my B, 2 and 5. So somewhere there has to be a c such that y equals, I don't know, any one of these values. Let's say 1, 2, 3, 4. And in fact, there's going to be 2 of them, aren't there? Let's shorten this up a little bit. Let's go to 1. Okay, from -2 to 1. Let's go there. They'll make it a lot faster. -2 to 1. Graph. So somewhere there has to be a c such that y equals 3 between -2 and 1. How do you find that? I want to know what x value gives me a y value of 3. The TIs are built to go forwards, not backwards. In other words, they're not built for y's to find x's. They're built for x's to find y's. Oh, 1, 2, 3. I want to know what x value gives me a y value of 3. Okay? So far, so good? Graph. Have we done this one? Second, calculate the intersection point. 5. I'm going to go to. First curve, enter. Second curve, they'll give you a display up here, y sub 2. Is this your second curve? You say yes by enter. And what's your guess? I don't feel like guessing. There. There it is. Is that number between -2 and 1? Yes, it is. That's the intermediate value theorem. Okay? And you learn how to find the intersection between two graphs. So that's good. Questions? Everybody that tried it, it worked? All right. Moving on. Oh, here's another example of the intermediate value theorem, f of b and f of a and c and f of x and all that other fun stuff. You can generate those graphs, but those are more trig functions than polynomials. So, use the intermediate value theorem to show that f has a 0 between a and b. Stop what you're writing and think about what it just said. You're not going to find the number. You're going to show that there's a number that exists. How do you show it exists? No, not by work. Well, work in the right direction, sure. Proofs? No, huh? Okay, a is less than b. What's the function value of a? If it's going to equal 0, what two values have to be there if it's something going to equal 0? Graphically speaking, how does something become a 0? Maybe the question's too hard. Did you calculate the function value of a? Is it? I don't know. Did you put it in there? -3 cubed is -27, -54. What is it? The function value of -3 is what? -15. What's the function value of -2? I don't know. What's -12? -2? No, -3. Okay, it's -12. What's the function value of -2? I don't know, -8 times 2 is -16, plus 20 is 4, minus 3 is 1. So if you have these 2 points, -3, -12, and -2, 1, is this a polynomial? Yeah, it's got the non-negative integer exponents. It's got variables. So what has to be true between those 2 dots? You have to connect them. And when you connect them, if you go from a negative y value to a positive y value, what does y have to equal at some point? 0. Does that make sense? Does it? Okay, let's go to the calculator. Y equals, clear, clear. Y equals x squared. Oops. Y equals x squared. Graph. Oh, I want to be on the standard zooming window. Second, calculate, window. Zoom 6. All right. Y equals x squared is a parabola. We all know what values of x make it equal to 0, don't we? What is it? 0. No surprise there. Second, calculate 0. Give me a number on the left side of 0. -1. Give me a number on the right side of 0. 1. I want to second calculate 0. I know the answer is 0. I just want validation from the calculator because I'm having a bad day. Okay? So the right bound is 1. Enter. What's my guess? 0. This one says 0. That's amazing. Anybody get an error message? What did your error message say? What did it say? No sign change. Anybody else says no sign change? Mine does. Mine should have. I can't believe it didn't. Second, calculate value negative. Let me try one more. No. Second, calculate 0. Let me try it one more time. -3 or 3 on the right bound. Delete. Why would it give you a sign change? Usually it gives me a sign change automatically. Why would it give you an error sign change? What's happening with the parabola? I'm going to play this one more time. There's thinking. There we go. It's no sign change. What's happening with the parabola? It's not going from a negative to a positive, is it? It's going from a positive number to a positive number. There's no guarantee y has to be 0 if you go from a positive to a positive, is there? No guarantee at all. But if you go from a positive to a negative or a negative to a positive, y has to equal 0 because it's a polynomial. The intermediate value theorem is in your calculator, and sometimes you have to be aware of that if you're looking for a 0. Obviously, there's a way to find that if you want to. What do we call that in the last chapter? We call it a what? Minimum. You can find the minimum if you want to find that. Okay? All right, so far so good. Ready? All right. Let's see. How much time do I have left? Having? How much time? 20? Perfect. How much? Good. There we go. All right, I want to get just a little bit farther than this. So, oh yeah, we showed that. If you have a negative y and a positive y, someplace y has to equal 0. We're getting ready to solve here pretty quick. I use the intermediate value theorem to show that this is true. You obviously put the a's in and the b's. This colon shouldn't be here. Sorry. So it should be minus 3x to the fourth. Now I showed you how to store this into your calculator to find the function value. So you could go 3, store to x, and you can just type it out. And you're going to find the polynomials are getting longer and bigger as you go. Sure. You bring your calculator up, and I want to quit out of that. Clear, there we go. X is 3, right? All right. So I have a lot of things over here. All right, 3, store x, enter. And now I have x to the fifth, x caret 5, minus 3x caret 4, minus 2x caret 3, plus 3x squared, minus 9x minus 6. Anybody get negative 60? Now, here comes the best part. 4 stored as x, and do the quick copy. That's what they call it this summer at Parkland. I thought that was kind of neat. And the other one's 134. So if you have one value at negative 60 and the other value at 134, what has to be true? Yeah, there is a number between 3 and 4 such that y would equal 0. Okay? That's all you have to do. It doesn't say find it. Well, we'll find them later. But right now, I want you to understand that if you have two numbers, one with a negative y, one with a positive y, at some point it has to equal 0. Yeah?
How did you plug the 4 back?
Oh, I hit second and enter and second and enter. You just scroll up on your calculator. You got to do it second and enter. And this changes. Second and enter, second and enter, second and enter. There it is. You can go back as far as you need to. Okay? Well, you can go back 20 times. Second and enter, scrolls back.
I'm talking about this because I set that in there and just came up with that,
Nice.
which isn't right.
No, it's not.
I don't know why it's doing that.
No, I don't either.
Thank you.
You do a lot of, there's 3 stored as x. Oh, because you have a multiplication sign instead of a plus sign between the first two terms.
Oh, that could be a problem.
Okay? Close. Oh, we're getting close. I want to do this. Hey! Match each equation to the graph. How can you tell which one's which?
Plug it in your calculator.
Well, you could, but
It's not A,
how do you know it's not A?
because it's x to the 4th. If you grab
No, there's another reason it's not A. What value makes x equal to 0 in A? 0, and the graph clearly is not touching x equals 0. So this one's out, because in this one, x would equal 0 and x would equal 1. And at 0, it's actually a double root, isn't it? That means it's tangent to the x-axis. In part B, what makes it equal to 0? 0 and negative 2. And negative 2 is actually a double root also. It's also tangent. Is the graph tangent at x equals negative 2? Yes, it is. At negative 2, it is tangent. But it doesn't cross at 0. C. It hits at negative 2. Yeah, but we need it to be tangent at negative 2, don't we?
Yeah.
So D is tangent at negative 2, crosses at negative 1, and at 1. Negative 2, crosses. It has to be D. So anytime you have something with an even power, it's going to be tangent. Something with an odd power, it's going to cross. It's a linear factor. Linear factors are lines, aren't they? And they cross as such. They look like lines when they cross as factors. Squareds are parabolas. So any factor that's a square is going to look like a parabola. So you see the little parabola right here, and you see the little line right here, and you see the line right here. That's because their factors are to the first and the second power. 10 minutes? That's quiz time. Okay. How far do we get? 12? This is still 12? Still 12? All right, so we'll get through like 1 through 13.
13's a different thing.
Yeah, you can try it. What page? 215? 216? 215. Okay. 1 through 13 off. Not bad. On this is